Now it's going ahead. So welcome to the session today. I'm Peter Underberg. I'm the founder of an activity called the Heat Academy. I'll tell you more about what we do in the Heat Academy. And we also have an advisory service called Nordic Heat. I'll come back to that. Just briefly, could I ask everybody to please turn off the microphones? Otherwise, we're going to get whatever you call it in English. Thanks. So just briefly on myself, I've been in this sector of district energy for the past 20 years. I'm based in Stockholm, but I worked across Europe. The first 10 years, I was heading a manufacturer of pre-insulated pipes, producing the pipes that we hopefully will be able to put in the ground also in Thunder Bay at some point. But for the last 10 years, I've been running an activity called Heat Academy, which is a training activity and an advisory service involving partners in, well, we are coming up to 30 countries now. The aim of what we do is to share experiences between regions in how to speed up and accelerate the development of heat networks and other related technologies. And base very much of it, as you will hear in the session today, we base a lot of it on the Nordic experience, where we have a lot of heat networks in operation since 50 years. Before we begin and we start, I launched the PowerPoint we're going to run. I'd like to introduce Kevin Conserve. You probably know him already, most of you. We are working together with Kevin and some others in delivering the pre-feasibility study. So I hand over to you, Kevin, just to say a few words.
Hi, everyone. Thanks for joining us, and I hope this session goes well, and we all learn something from them. I've been working with Peter for the last 6 months or so, and I'll be quite honest with you, maybe a little bit less. I've learned a wealth of knowledge from him in that time frame, and this is a project that we're all very excited to work on together. Just for some background, Conserve Engineering, I know quite a few of you. We're a local engineering company based in Thunder Bay, and we're going to be providing some services to CRIBE and the city of Thunder Bay for this project with respect to the heat network with Peter and the biomass with Vince Rudder and biothermic. So there's a whole team collaborating on the project in the background to put together a feasibility study, a pre-feasibility study, to ensure that a project such as this is actually feasible. So that's what we're looking at, as a go, no go, see if this project is a feasible project for the city of Thunder Bay. And we're using the expertise from Peter and his group and Vince Rudder and his group to put together a comprehensive report to see how feasible it is.
Thanks a lot, Kevin. Thanks, Kevin, for that. And again, before I launch the PowerPoint, I'd like to hand over to you, Chris, as well, to give some background to why we are here today.
Thanks, Peter. Thanks, Kevin. And welcome, everybody. It's excited to see the participation here. My name is Chris Walton. I'm the CEO of CRIBE. We're the Center for Research Innovation in the Bioeconomy. Many of the folks in Thunder Bay probably you're familiar with me over the years in my role, either when I used to work for the Bowater Resolute at the time, and with our management consulting company that I owned for a number of years, doing a lot of work with the city and other organizations around sustainability, climate change adaptation, and whatnot. For the past 3 years, I've been running CRIBE as the CEO, and for those who don't know who CRIBE is, Center for Research Innovation in the Bioeconomy was formed in 2009. We're an independent nonprofit with a mandate to identify and to work on identifying innovative new applications of forest biomass for the province of Ontario. So our mandate is to work within the boundaries of Ontario. However, we do work extensively with other provinces, national and international partners like our friends in Sweden and Finland, to identify innovative and new sustainable applications for forest resources. So we are funded by, we're an independent nonprofit. We are primarily funded by the province of Ontario through a variety of agencies, as well as the federal government, primarily NRCan and FedNor. Since 2009, we've deployed about $27 million in projects across the province of Ontario. These are mid to late stage technologies, primarily with a focus on commercial deployment and demonstration. So one of the areas of investment that we have done is on biomass and biomass heating and biomass energy. We've provided support to folks like Biothermic. We've provided support to Confederation College, as well as other areas where we've looked at energy systems with biomass. So why we're here today is that we've also received some money to do some regional case studies across the province to identify new opportunities, first-in-kind opportunities in Ontario to utilize biomass. So we are based in Thunder Bay, and we were involved a little bit in the consultation around the community energy and emissions reduction plan with the city of Thunder Bay. And for those who are involved with that, there was a commitment to look at district energy or district heating as a potential option for low carbon energy option for the city to help meet their goals. So we started chatting with the city, some of the local business owners, the business associations, some of the big landlords in downtown Port Arthur, around some interest in if we were to put a little bit of money on the table to do a pre-feasibility study to see if this would work in Thunder Bay. So that's how we've gotten to where we are today. So we are investing in this in partnership with the city of Thunder Bay, and CoStar Engineering and Biothermic and Peter's group were the successful bidders on that job to do the pre-feasibility. So we're looking forward to seeing the results. And part of our commitment to this as well is to do a number of these webinars. Really, the objective of this first one, I won't take take too much away from Peter's presentation, but our objective is this is sort of an overview, District Energy 101, and we're hoping sometime later this fall, into December, we'll be able to actually present the results of the pre-feasibility study that they're working on, and with a little bit of a discussion around how we might be able to make this work based off the results. So thank you, everybody, again. It's great to see everybody. If you want more information on us, you can see us at cribe.ca, or our industry collaboration network is next4.ca. Thanks.
Thanks a lot, Chris, and great to see that we have so many people joining us today, 31 as we speak. And as Chris said, the purpose of the session today is to introduce you to district energy, heat networks, thermal networks. There are lots of names of the same thing. And we're going to base it on lots of the experiences we've done in the Nordic region, but also together with my colleague and partner, Michael Jacobson, who you see on the screen, who's actually calling in from Beijing in China, based over there, who will be able to introduce himself in a short while. But I will launch the PowerPoint slide deck now. Please interrupt. We're not that more the people than that. If you have questions during the session, please send in a chat in the chat room, and we try to respond to it either during our presentation or just as we finish the formal presentation with the PowerPoint. It is supposed to be an interactive session, so please don't hesitate to ask questions as we move along. So I'll launch the PowerPoint deck now, and there we go. So I hope that's visible to everyone. So just a quick recap on who we are and what we do. There are plenty of projects underway across the globe now, particularly in Europe, and we see more and more district energy projects evolving in Canada, in the US, and as Michael will mention, over in the Asian region. A problem with district energy is that it's often regarded as a new technology. There is a lack of experience locally in how to implement this in an affordable way, and many projects tend to be tied up in feasibility studies. Our aim is to try to break down this wall, which is often stopping projects, that they become too costly, both in terms of capex, but also in the operational cost. There are challenges with the revenue model that has to be resolved, and there are obviously risks related to these projects. So our ambition is in different ways to assist local communities, local engineering companies, communities, universities, etc., to develop a local capacity, to build a local capacity to deliver these kind of schemes. We do that through advisory services, we do it with training, and we do it with capacity building. I'll very briefly take you through what we do. In a project like this, we have already launched the initiative in collaboration with Conserve and Biothermic, working on this pre-feasibility study. We are basically having the role of being a critical friend to Kevin and the team, providing our assistance and our experience to the project and to the pre-feasibility. The other area we focus highly on, strongly on, is on the skill side. And here, if the project moves forward into delivery, we will do hopefully the similar development as we do in other locations where we are active. We try to develop a close collaboration with local universities and colleges, again with the aim of developing the local capacity to actually delivering these schemes locally, not being dependent on external and people coming from other countries. And then finally, if projects move into delivery, we also have a service where we facilitate market entry and matchmaking. That will be, if you build a heat network, there will be a need to involve suppliers from other markets, other regions of Canada, but also from abroad. And there is a need to facilitate market entry for these companies to find our local partners and so on. So this is basically what we do. And now the project we're going to focus on today is a bit more limited, obviously, at the current stage. We are looking together with Kevin and the team at how can we make this possible to connect a number of buildings in downtown Thunder Bay to a heat network, which is supplied to which this heat is supplied from a biomass based heat unit somewhere in the proximity of downtown Thunder Bay. So that's the objective, to find, can this be done in an affordable way, and in that case, how? And this is what we bring in, the experience from Nordic Heat. I will not dwell too long on these slides, but what we try to do is to help bring in the experience, the know-how we have developed and our partners have developed in other regions, and thereby giving the project in Thunder Bay a faster move through the process of developing and implementing the network. So we work with companies and councils, primarily councils across Europe, and also, which we don't see in this slide, also in Asia. The training side, as I mentioned, what we try to do here is always to build up local partnerships, and we can come back to that in the next session when we are presenting what we do, what we have come up with in the pre-feasibility. So what we're going to try to do today is to take you through very quickly through the first 4 steps in a journey on how do you decarbonize heating with district heating, with heat networks. What's possible? Why are heat networks a very good idea to put in place? It is not only about heat, but as you will hear, it's also about socioeconomic opportunities for the community. We will also touch upon what heat networks really are and where they are best located, what are the best locations to actually implement them. In the next session, which Chris referred to, which will probably take place somewhere in early December, we're going to be more action oriented. How do you actually do these, implement these solutions? Who is involved? How do we do it in practice, and how do we get started? But today it's more the background. Why is it a good idea, and what is it really? We can skip a few of these slides, and we skip that one and move into the actual session. I don't think I need to spend too much time talking to you about this slide. We are all fully aware of the situation, the climate emergency, putting a pressure on all economies globally to reduce the fossil fuel content in the economy, and thereby decarbonizing our way of living and our activities. So this is a very critical issue, as we are all aware. What has become another driver for decarbonizing heating and other solutions in Europe, and I believe potentially also in Canada at some point, is this slide that we've seen gas prices increasing extremely rapidly across Europe. In the UK, in some regions, you have gas prices today which are 5 times higher than what they were in just 6 months ago. And this is obviously totally unsustainable for people to have this. And we have to keep in mind that in most countries in Europe, Central Europe and the UK, some 90% of the buildings are heated by gas. So this is a big topic and a big driver for change. However, doing this change is very, very difficult, very challenging. We talk a lot about wind and solar, but globally, only 10% of all energy, primary energy input comes from solar and wind. We have another 10% from nuclear, from biofuels, hydropower, but the vast, the bulk of all energy we consume is still fossil fuels, oil, coal, and gas. We actually consume more now than we did 5 years ago, and we probably will consume even more in 5 years than we do today. And this is a big dilemma. How do we decarbonize when we are so dependent on fossil fuels? This is another way of saying the same thing. Some 80% of all energy, primary energy input to our economies globally has come from fossil fuels. Even if we look back to 1965 as this picture, it hasn't changed very much. And considering what is the task now, looking at the climate change agenda, we basically need to, cut down massively, perhaps up to 60-70%, the dependency on fossil fuels just in the next, 8-9 years. And to replace all that fossil fuel with wind and solar, I think nobody believes that will become possible. So we need to find another way of addressing this. Parallel to that, we implement these kind of sustainable energy solutions. But just doing wind and solar will not make it, particularly considering that we expect a doubling of the demand for primary energy in the next 15 years. So we have a big challenge ahead. And we are faced kind of with a devil's alternative. If we don't provide energy to our economy in terms of fossil fuels, we're going to have social unrest. And we've seen quite a lot of that in Europe in the recent years, not only linked to pandemic, but also linked to that companies are laying off people. Traditional industries have to close down. But unless we address the climate, we will have even bigger fires, which we've seen as well. So it is a really big dilemma. The question is, what can we do and where do we start? Then we need to look, and now we move into the topic of district energy. It's not a silver bullet. It's not something that can you implement district energy and then everything is resolved. But it has a very big impact on the problem, and should definitely be one of the areas to prioritize in the coming years. The explanation to this is that if we look at the total primary energy consumption in an economy like Canada, but similarly in the UK or Belgium, some 40% of the primary energy we put in, and most of that, as I said before, is fossil fuels. 40% of that is to heat buildings. We don't often think in those terms. We talk about cars, we talk about airplanes and so on, but a big chunk of the energy we consume is actually to heat our homes, at least in the regions where we live in Canada and in Sweden, in the northern parts of the world. This heat consumption in Canada, as in other economies, having a lot of gas as a source of heating, and there you can bring in basically every single country in Europe except the ones in the north. They use gas. So heating buildings represent from 35% and in some cases up to 50% of the CO2 emissions in countries and in cities. So that's why heating is a very a low-hanging fruit. We need to tackle it, and it actually is a fairly easy, technically easy at least, solution to implement. And that's what we're going to try to present today. We have proof of the concept from the Nordic region, having done this for the past 50 years. So again, this is why we put district energy into this context of climate emergency and decarbonizing heating. Now, when doing this, obviously, heating is not the only solution. Parallel to developing heat networks, we also need to look at ways of reducing demand for heat. And to do that, we need to spend money and investments on insulation technologies of our buildings. In many cases, it is also worth to consider combining heat networks with heat pumps. So they're not necessarily in competition. We see heat pumps, and you're going to hear from Michael's presentation that heat pumps often constitute an important source of heat for the heat networks. So this is kind of the windfall. These are the fruits that we need to pick in the beginning. And then as we start moving up into the tree, then we can move into the more complex solutions. We should not try to pick the apple on the top of the tree first. We should go for the windfall, as I said. Nordic experience, and I have a very hands-on experience of this myself. This is the house where I grew up. And I remember as a kid, we carried logs up the stairs in the evenings to keep them close to the open fireplaces we had. And very cozy, obviously, but not very convenient. So in early 70s, my dad and a lot of other dads in Sweden, Denmark, and Finland decided to go for central heating. So there was a lot of buildings being converted to central heating, but using a central boiler based on oil. And if we look at history, looking back, that was not a very smart move, but nobody could foresee that. Oil was the main source of energy for everybody in those days. But then 1973 came about, and Yom Kippur War in the Middle East, and suddenly the world was faced with an energy crisis. And there are parallels, even though we are not looking at wars today, but there are parallels to the energy crisis we are faced with today, which might now more on a global level drive decarbonization and replacement of oil and gas for heating purposes. Sweden being fully dependent on imports of oil, and we didn't have any sources ourselves. So what could we do? Well, we started immediately following the oil crisis to start insulating homes. There were lots of government incentives and support activities to help people insulate, to be able to reduce the demand for heat in the first place. In parallel to that, we started to expand the heat networks. There were heat networks in place already by then, but not to the extent we have today. And I remember our house, we got a very tiny plastic pipe network connected to our home, which was connected to a small-scale bio boiler in the village where we lived. Today, we see more the big-scale district heating pipelines being implemented across the Nordic region. Another way of showing the change was that this is a city in central Sweden. In 1964, most homes were heated by biomass, but in open furnaces, open fireplaces. So you had a lot of smog in the cities in those days. The same city 20 years later, no smog. 3 different industrial waste heat sources provide 90% of the heating to the city, all distributed through a heat network that is connecting every building in the town. So that helped to reduce the dependency on oil, but also it helped to reduce the pollution levels in the cities. And this is actually a big driver, perhaps a bigger driver than climate in parts of the world. For instance, in Chile, this is a big issue to get rid of individual fireplaces and to thereby get rid of smog. Today, the home where I lived is connected to a huge regional heat network. Some 500,000 people, customers, are connected to the same network. There are some 20 different heat sources to the heat network, and as you can see, it's a large region. By air, it's 60 kilometers from the north to the south of the network, and it's obviously several hundred kilometers of pipes in the ground. As you can see on the graph, in the early days when we started building the heat networks in Sweden, they were very much based on fossil fuels, the black sections here, and to some extent coal and gas. But over the years, it has been possible to basically completely decarbonize the heat provided to all these homes. A big source of heat is what you can see on the left-hand side on the screen, and that's local industries, where you connect the grid to local, in this case, a chemical industry, providing waste heat from their industrial processes to the grid. That has another very positive factor. The chemical industry, previously, they let the waste heat out into the ocean, and they couldn't get any value from the waste heat they generated. Today, they sell the waste heat to this district heating grid, and that has been enabling them to make enough money to actually maintain production. That gives them a competitive advantage to maintain the production in Sweden. Sweden today, if I could ask everybody to please turn off the microphone. Thanks. So in Sweden, from the early days we had a big, from all small scale heat networks, we had a big drive through the oil crisis in the 70s, and today we've reached a market share of approximately 55% of all heat provided in Sweden. It comes through heat networks. If we look at the bigger cities like Stockholm, where I'm sitting right now, some 90% of the buildings you see on the picture are connected to a heat network. And the bulk of the heat is coming from a fairly new bioheat plant that you see on the left-hand side, which provides approximately 25% of the heat required to Stockholm. Now, I assure you, we are not looking at building something of this scale in Thunder Bay, at least not in the feasibility study we are looking at now. But the principle is the same, to make use of waste wood from forest industry, and I understand you have a big forest industry in Thunder Bay area, just as we have in Sweden. It's not about cutting down forest, it's about making sure we can utilize waste material from forestry. Benefits have been quite important. I mean, the project of implementing heat networks in Sweden, and similarly Denmark and Finland, was all driven by, as I mentioned before, the energy security, the need to find an alternative to the oil we used prior to the oil crisis for heating our homes. But then that had obviously a very strong impact on the balance of trade, that rather than buying expensive oil from abroad, we started to use local resources, like local, as I mentioned, waste material from forestry, waste heat from local industries. So kind of the money stayed in the country, and not only that, it stayed in the cities and the regions. And the money that was saved in that way was used to actually further extending the heat networks over time. And it has taken obviously 50 years to build the heat networks you could see, for instance, in Stockholm. It's not something you do overnight. Then in those days, in the 70s, I don't think many people worried too much about the climate, but the pollution was an issue. And that was another positive benefit from implementing these solutions. And then finally, it happened to be that the customer benefits were very good. having heat networks. As Michael will highlight in his presentation, it is the most affordable way of heating a home in Sweden, similarly in Denmark and in Finland, because of scale. Once you get scale and you get lots of houses connected to the same system, you get a massive scale effect, which you would be able to see also in Thunder Bay, even with a relatively smaller scale heat network. It has proven in Sweden, and that's important to emphasize, energy is deregulated since early 90s. So district heating competes in an open market versus gas or any other heat source. It doesn't receive any special benefits. There is one benefit though, it's if you use district energy in a good way, that we have a CO2 taxation in Sweden, a carbon taxation. So that gives benefits to sustainable heat sources to the heat network. So if we look across Europe right now, the red part of these columns is the current market share of district heating. So in Europe overall, we have 8% market share in the total heat market for district heating. In the Nordic region, as you can see, we have much higher levels. In Denmark is even beyond 60%. Eastern Europe even more. It's the heritage from the Soviet times. The problem they have is that they have very inefficient systems, so they need to replace the pipes are leaking quite heavily. But we see a very, very strong trend across Europe now to rapidly expand district heating, enabling a quicker transition from gas to alternative heat sources like industrial waste heat, biomass, and similar. If we look at the UK, they have set a very aggressive target to take district energy from current 2% market share to 20% in the next 20-25 years or so, which is a very, very tough target to reach. Just referring to, I mentioned earlier that I used to be selling pipes like the ones you see on the left-hand side. In the UK, to take district heating to 20% market share represents some 25 million 12-meter long pipes. Not all of them of this dimension you see on the left side picture, but it's quite an important number of pipes. And it's not the pipes only, but we need to excavate and get them down into the ground. So that will be a significant task as we move in to the future. I think I'll stop here now and I hand over to you, Michael, and you take on from here.
Thank you very much, Peter. Yeah, my name is Michael Jacobson and I'm part of Peter's team. I started out in the business some 20 years ago, being responsible for the design and operation optimization of Stockholm district heating and district cooling system. For the past almost 15 years, I've been located in Asia and mainly carried out projects in China and then surrounding countries like Mongolia, Kazakhstan, Uzbekistan, and these countries, and developed and optimized some 70 district energy projects. I will try to share my screen and give an introduction to the concept of district heating. So like Peter said, one of the main drivers in many places for district heating is to remove the local pollution. We had the case in Chile where that is happening. This is a photo from our office in Beijing. And as you can see, that the left picture is not that long ago. It's back in 2014. And today there has been a great shift. And this is thanks to district heating. However, we should be aware that district heating as a system has been operating in Beijing. This is a picture from Beijing for more than 50 years already. However, from the beginning, the technology was originated from the Soviet era and not that efficient district heating systems. For the past decades, there has been a conversion towards more, we can say, Nordic-inspired district heating technologies, and we can see a tremendous increase in efficiency and thereby also the pollution removed from the city. For the past decade, there have been some 500 boilers closed down in Beijing alone, which obviously has then resulted in this much better local conditions. There are other drivers, such as with the district heating system, we're able to reduce the installed production capacity because all buildings do not use their peak demand at the same time. So we have something called the diversity factor, which allows us with a centralized system to reduce the installed capacity. We have a system efficiency as well that is much higher due to that we achieve it from scale advantages, but also as we use, we can say, industrial grade components in the system. The reliability and safety is increased as well with the district heating system. And one of the important other benefits is that the district heating system is future-proof. Once we have get the district heating network in place, we are free to change the production technology or the fuels as we are developing. So it is future-proof for new fuels and so on. And this is something that we have applied in some cases. For example, when there have been available renewable electricity that has been curtailed, we have been able to utilize that while developing the district heating system. And then when the electricity grid has been reinforced and these bottlenecks in the electricity grid has been removed, then of course the electricity is better to use for other purposes than to heat homes. So then we have switched to other production facilities while we already have invested in the network. So these are some of the benefits with district heating, and we define it as a heating system with one or more centralized production facilities for multiple buildings. Sometimes they are big, sometimes they are small. It totally depends on the local conditions. If we look at the development of the district heating sector, it started out more than 100 years ago. And at that time, there was mainly steam systems with very high temperature and quite low efficiency. As time has passed by, the development trend has been that we are reducing the temperature level in the district heating system, and we are increasing the level of integration of different kind of heat sources, but also integration to other energy systems. Nowadays, it's very common to integrate, obviously, the heating network with the electricity grid, with cogeneration plant and so on, but also to integrate with the cooling systems, often distributed because they are, per definition, smaller scale. That we're utilizing a lot of waste heat, and that is possible to do as we have lowered the temperature level in the systems. So the typical trend has been that we are lowering the temperature, utilizing local resources, and it is we can say a multi-energy system. That has been the typical trend. We often talk about smart district heating nowadays, and what do we mean by that? Because often we start to think about intelligence, we think about data and IoT and these kind of things, typically IT-based tools. However, when we talk about smart district heating, we think about a number of characteristics that we should achieve. So we want the district heating system to be flexible. And by flexible, we mean both in terms of being flexible for demand changes on daily basis or hourly basis and so on, but also flexible when it comes to development over time. Then obviously also in regards to intelligence, to utilize smart IT tools for optimization, but also innovative engineering solutions. Integration, as I mentioned, integration to other energy systems and utilization of local resources. Efficiency, of course, and one of the very important things to be able to call something smart is that it is competitive. Even though we can say district heating nerds, we think it's very important to develop district heating schemes in a way that is feasible. We should not develop district heating systems where it is not competitive and where it does not make sense. So it's not a solution for everywhere, and the size can very much vary depending on the local conditions. And the last one, obviously, of course, this kind of system has to be reliable and safe. We have seen many accidents over the years, often accidents that, I would say always accidents that could have been avoided quite easily. It's very important to focus on the reliability and safety. Except of these characteristics, we also have to think of it from different dimensions. Both we have to achieve all these characteristics through the whole system value chain, from the production, transmission, distribution, and consumption. But also we have to think about it through the whole project value chain. So we have to start to think about these characteristics already from the planning phase, through the design, implementation, and then further to operation and maintenance. It's very important to keep this in mind, because if we are not fulfilling this throughout the whole chain, we cannot achieve a good result in the end. With this, it's very important with heat planning, where we're starting, or feasibility studies and so on. So we often talk about to do scenario analysis, where we look at always taking departure from what kind of demand we have. We are looking into what are the different available resources. Like Peter said before, in Stockholm, for example, about 15% of the heat in Stockholm is based on heat from the sewage water system. So with the heat pumps and utilizing the waste heat in the sewage system. And there are a lot of different heat sources available in the city, and I will show that a little bit more later. The key to succeed with the development of district heating system is what we call heating demand density. Because the heating demand density says what is the heat load in a certain area, because that will decide whether it is financially feasible to develop the district heating system and invest in this network, and especially the network, I would say. So heat demand density is something that is very, very important in order to find out the feasibility of a district heating system. And we do look into different scenarios, and we finally do the technical, financial, environmental, and institutional benefit analysis. The design is important as well. We have to remember that district heating systems is a system. It's not just a technology. It is a system that is dynamic. So it's very important to have a certain approach when it comes to the design. It is large scale, and there are delays in the system and certain, like I said, dynamics. I will come back to that later. So what does it comprise of? Well, obviously we have the different production facilities. In the picture to the left here, the red square are production facilities in the city center of Stockholm. The black lines are the pipeline network. We have some pumps around in the system. And at the building level, between the network and the building heating system, we have a substations, which is illustrated in the top right corner, which is simply the interface between the network and the building. These are the main facilities in a district heating system. We have a supply pipe that is supplying the hot water. The heat is transferred into the building, and then the cooled water is recirculated back to the production facility and heated up again. So it's a closed system. Where in a system like Stockholm, the water leakages are extremely minor. The level of the water losses is less than half of the total volume in the network per year. It is very, very, very little leakages, and 90% of these leakages is because there are maintenance work, so it's on purpose tapped out the water from the system. Again, that comes back to the reliability and safety of these kind of system, and that there are professional companies that are responsible for the operation and maintenance. Upper left shows we have the outdoor temperature on the x-axis. So this is again an example from Stockholm, from -20 degrees, which is the dimensioning outdoor temperature, and the heat is supplied all over the year because we have domestic hot water that are using district heating as well. And as you can see, it is pretty linked to the outdoor temperature, the heat load. However, there are other factors that are influencing the heat load as well. And the curve in the bottom left here shows the black one is how the typical daily curve varies in the weekdays. And then we can say in the weekends, the curve look a little bit different. It's typically because people are simply waking up later in the weekend. And that's how we can see how the demand, the daily demand curve changes behave. So what is influencing the heat load in the district heating system? Well, the outdoor temperature, obviously, but also the wind and the solar radiation, and then also internal appliances. So all this is influencing the heating demand. Traditionally, in the past, it has been very common to, at a certain time, look into, okay, what is the temperature at the right now? What is the strength of the wind at the moment, and what is the solar radiation? And then we are controlling the heat supply based on that. However, due to the thermal mass in buildings, these different factors have different impact over time. So nowadays there are IT tools to help to predict what the heat load will be in the future, and thereby result in an even more efficient energy system. As I mentioned, it is a system, and this is part of the Stockholm system. And as we can see here, this illustrates how long time it takes for the water to go out in the system. That's why we have to be prepared already hours before the specific demand is required. However, there are great tools to achieve this with very, very high accuracy today. So the control of district heating today is not really a challenge anymore. Some examples of heat recovery. So I mentioned about the sewage water heat recovery in Stockholm. Also, the possible to recover heat from data centers, from industrial processes, and we can also use different other, let's say, water sources such as sea or lake or rivers and things like that, and together with heat pumps supply heat to the district heating system. In Stockholm, I think it is about 15 data centers that are feeding in their surplus heat into the district heating system. Then it can go even further, where heat is recovered from supermarkets, for example, from the say, refrigerators and things like that. There are also common that swimming pools are heated by the district heating system, and some consumers have their own production facility also. So sometimes they are consuming heat and sometimes they are producing heat and selling it back to the district heating system. So this is again about the integration, we can say, in the district heating system that is of great importance. There is also opportunities for carbon capture, and if there are biomass, like it is quite a lot of biofuels in many systems in the Nordics, it's possible to achieve not only carbon neutral, but even we can say carbon negative or climate positive by the carbon capture technologies. And this is something that has been researched for the past, I would say, 5 years. That has been really great attempt with the carbon capture, and now it's getting commercialized, both in countries like Sweden, but also Germany and other countries have quite mature technologies when it comes to carbon capture. It's quite interesting to look into that. Thermal energy storage is another technology, and I think in the coming sessions that we will have, we will talk more about the opportunities with thermal energy storage, and this is simply to store heat when it is available and use it at a later time. This can be both on daily basis or weekly basis, but also over seasons. If we have heat at some point. We can store it for even for months and then use it at a later time. And there are different technologies when it comes to the thermal energy storage. I think I will jump here. It gets quite detailed. So again, the design and the planning is of great importance to get right from the beginning, and also to be able to reach the level of financial feasibility. Because there is no doubt, it is not the case that the bigger necessarily is better. It's very important to look into the local condition and develop the system accordingly. Like I mentioned, I personally worked with close to 100 district heating and cooling systems around the world, and I would say all of them are unique. There is a lot of experiences to take advantage from when we're developing new district heating system. But however, each and every system is unique, and it's very, very important to look into the local conditions. It comes both when it comes to the demand, how much the demand is, what kind of demand it is, but also what are the available resources and so on. So if you remember in the beginning, we talked about the first and the second and the third and the fourth and the fifth generation of district heating. It's not possible to say that the fourth generation is necessarily more suitable than the third. It's not always like that. It totally depends on the local condition, and based on that way of categorizing the generations is typically that district heating systems have some characteristics from a number of these different generations. Obviously, the goal is to have as low temperature level as possible. That would always be the goal, to reduce the heat losses and achieve higher efficiency. When it comes to the cost of district heating, there has been a lot of researches done over the years. What has been focused in the past is to ensure that the district heating systems are financially feasible even for low energy buildings. Because as we move on, and that is the case in the Nordic countries as well, that it's not only because it gets warmer due to the climate change, but actually the consumers are carrying out energy efficiency measures. So even though the networks are expanding, the total heat load might be reduced, which means that the heat density that I mentioned before, which is of great importance, is getting reduced. And that's why we have to make sure that the district heating systems are financially feasible even for relatively low energy demands. And that is of great importance. And that has also been a driver, I would say, for the later generations of district heating, because when we lower the temperatures to a certain level, we can start to utilize new technologies like plastic pipes and these kind of things, other technologies that makes the implementation, both the investment but also the implementation cost lower than it has been traditionally. So with these kind of evaluations that's been carried out, it has been proven that district heating definitely is financially feasible as long as it's developed in the right way. And this is the key, as long as it is developed in the right way. I will not go into details of the figures here. You will get the slides. You can look into the comparison between different countries and different alternatives to district heating, but it has shown that district heating is definitely competitive. This is one research. There are other researches done. This is done by the Euroheat and Power, where district heating is compared to other standalone solutions. And we can see here to the left, district heating, the cost per year compared to an oil boiler or wood pellets. So these are individual solutions for buildings. And district heating is then competitive. With that, I think, the last one is about the tariffs. I think it's of great importance that the tariffs are designed so that it is stimulating energy efficiency measures. So nowadays, the tariffs are often comprising several parts. One part that is related to the consumption, which then is something that the consumers can impact. If they use less energy, they will also pay less. Then there is one component that is related to the capacity. which is something that they also could influence, but also a component about efficiency directly, which often are applied that the ones that are most efficient, they will get a reduced heating bill, while the one who are less efficient, they will get a penalty charge. And this is to stimulate energy efficiency measures at the consumer side. With that, I think I will hand back to you, Peter.
Thanks a lot, Michael, for that. I will add a few more slides and then we're going to open up for questions. What I will do, I mean, what we try to do now, and I fully appreciate it's been a lot of information in a relatively short period of time, but we try to cover the different aspects of how you build a heat network, the more theoretical aspects of it. In the next session, an upcoming session, if there is more than one, we're going to focus very much more on how to do it in practice. And then it becomes more tangible and concrete. Just to give you an idea of what we're going to focus on is, despite all the complexity that you might have felt when you listened to the presentations by me and Michael, the topic of district energy is really about three things. It's about demand for heat, and that you have a in this case, what we're looking at now, sustainable heat solution, and then to connect the two. That's really it. And for the project now we're looking at Thunder Bay, we're going to keep it relatively simple as well. It's not the size of network, even though the principles are the same. The size is not like the one in Stockholm or in Beijing. Over time, it will become hopefully of the similar size, and then other complexities will enter. But at this stage, it's about getting the pipes in the ground, connecting the buildings, and making sure we have an affordable and sustainable heat source. And you have a unique opportunity, I would say, in Thunder Bay with a biomass availability to biomass locally. It's much more challenging in areas like in the UK or Belgium, where they don't have the forests to source heat from. I also looking at the upcoming sessions, what we're going to focus on is the process. How do you implement a heat network? Well, we start with conservation. We address the buildings. You remember what we did in Sweden back in the 70s. I mentioned that the first thing to do was to start insulation, investing in insulation of buildings. And then once that has been done, we start building a smaller scale heat network, similar to what is now being subject to this feasibility study. And then over time, and we call that building the donuts, a small circular network connecting a number of buildings. And then you might build another donut somewhere else. And over time, you connect the donuts, and then you can convert and find other ways of heating your buildings. And I got a slide for describing just that. And I used that as the final slide before. And it is that size matters here. If you have only one house, could I ask everybody to please turn off the microphone? Thank you. If you have only one house, you're fairly restricted in the options of how to heat up the house. It's basically heat pumps or a gas or oil boiler. But as soon as we look at combining a number of buildings, like is the case for the feasibility study in Thunder Bay, that gives us a bit more options, options. We could have a combined bioheat solution. We could have a combined gas CHP. And having it combined reduces the cost of operating it, but it also helps us to reduce pollution levels. If we centralize the biomass burner, we can invest in very advanced filtering systems, reducing pollution levels to close to zero. Whereas if you have an open fireplace in your home, you can't do that, obviously. And once you get really big, then we can look at other solutions as well. But I think what we are looking at in this case right now is to look at the buildings, what can be done to the buildings, and how do we connect these buildings. The more we can reduce the demand for heat, the more we can reduce the size of the pipe we put in the ground, and thereby reducing the capex and improving the financial viability of the project. One last slide, and then I will turn off the PowerPoint. I think looking at projects like this, often it's not the technical challenges that are the difficult ones. The big, in our experience, the absolute biggest challenge is to convince all the stakeholders that this is a good idea, to involve political institutions, political decision makers, the general public, obviously the customers, investors, and other stakeholders that can benefit or influenced by it. This is the key thing, and that's why I think it's such a great initiative by CRIBE and the City of Thunder Bay to launch these. I know you've done a walkabout already together in the city, and to run these sessions in parallel to a pre-feasibility study. Once you've produced the results of a feasibility study, it's too late to start involving stakeholders. So I think as a final word, this is a very great initiative. So by that, I'll close down this part of the session and open up for conversation, discussions. If I launch out, Chris, did it make sense to you listening to what we had to say?
Yeah, no,
or
thank you.
Do you regret that you started thinking of district energy?
No, it's all good. Thank you. It's lots of information, and we're going to obviously share the slides so folks can dig into some of the tables and whatnot. Can you just chat a little bit more about I know you've touched on it, but the importance of, I think you've talked a little bit about that hybrid. It's a bit of a hybrid system. You want to go with energy efficiency, but then there's steps there that you just don't jump right into. You don't jump right into a district energy system. You want to make sure that it's to minimize the size and the efficiency. You want to ensure the buildings are efficient and whatnot. Can you touch a bit on that, but also talk a little bit about timing as far as retrofitting buildings and other things, right? If you've got older, some of the equipment, some of the buildings in the downtown core are older. They've got probably older heating systems. There's equipment cycling. When does it need to be replaced? What's the best time to do it? Just comment about that, because I think people get scared of the initial retrofit, but there's lots that has to lead up to that.
Absolutely, I can comment on that, and I'll invite you, Michael, to join shortly. But I go back to the slide I showed you and where we ended the session. This is very much the process to do it, and it's not a new invention. That's the way, as I showed you, the way it was done in the 70s in connection to the oil crisis. The first thing you should do is to conserve, to reduce the demand for heat, because that's something that you can do relatively quickly. And it's often the cost benefits of that are often very, very good. You get a quick payback of any investment in conservation and insulation of buildings. And that combined with building a small heat network, which is what is on the agenda today or being considered in Thunder Bay, that's enough for the time being. To do that, then you have the basis from which you can grow and develop the system. It doesn't really make sense, I fully understand that, for you to compare yourself with systems like the ones in Stockholm and in Copenhagen and so forth. But over time, a system that is starting with these small donors will evolve into that. I like also to comment on what does it mean to conserve buildings? Well, that's kind of an interesting area also for us who have been in this sector for many years. The traditional way, and what we did back in the 70s, what we often have done, I'll make sure I have my pointer, would have been to change windows to fabric and so on. And had you asked me 5-6 years ago, I would have said this is what we should do immediately. However, with digital solutions now coming into our industry in a very quick way, and we see it spreading all across Europe now and beyond. Also in the industry of heating buildings, there is a big saving potential to be done in a much more cost-effective way by implementing sensors in the buildings, connecting these sensors through wireless connections to kind of an artificial intelligence solution that in turn is connected to various other data sources like weather forecasts, etc. And the idea behind this is that you learn, the system, machine learning system learns how the building operates, but it also learns that if we have sunshine tomorrow, then I should turn off the heat system today, because there is this delay in getting the temperatures down. Normally, what happens is that we open up the windows because suddenly there's a sunny day, and we do that because we didn't turn off the heating yesterday. Had we been more, ready to do that, having the tools to be able to do that. So these are very much, and this is something we have discussed also in the team behind now doing the feasibility study, to look at these options as well and potentially identify 1 or 2 buildings where we could run a pilot test. The fascinating thing with these solutions, they sound very expensive, but they are much less expensive than actually changing windows. And short term, the impact of these kind of solutions is quite impressive. I'll leave to you, Michael, as well, to comment on this and to Chris' question.
I think you covered it all, Peter. I think it's right. We have to start on the demand side and look into where it makes sense to we can say modernize the buildings if necessary, and to what extent, and simply figure out where it makes sense to develop into a district heating consumer, because there will be buildings that not necessarily will be connected to the district heating network where it is simply is not feasible. So it's something simply that we have to look into here already in the feasibility study to see what are the different let's say building heating systems and so on, and what are the suitable path to develop.
And this is also why we not necessarily always emphasize district heating. That's one of the technologies, one of the core technologies for this, but the objective is obviously here to decarbonize heating, and that can be done with different means. It's not uniquely done with district heating. It could be heat pumps, it could be a combination of the two, as Michael mentioned, but it could also be investments only in building efficiency, because that's the most beneficial solution. Did that give you answer your thoughts on that, Chris?
Yeah, that's good. So,
and I should add to this, which I mentioned, that it sounds for many people odd that you want to reduce the demand. I mean, that's not the idea of a market economy. You want to increase the demand. But here in this case, the more we can reduce the demand, the less expensive will it be to build and operate the system. We can go down in pipe sizing, dimension of the pipes, if we can reduce the demand, and then we can much easier, build a business case around the investment if we can do that. So there is a lot of, and also quite a few of the energy companies in the Nordics now, this is how they compete. It's not only by selling heat, but also bringing in solutions and advice to customers how to help them to reduce the demand. We have as an experience in Sweden, when you connect a building to a heat network, a year later they consume 20% less than they did before. And often people have asked themselves, why is this happening? But you get a focus on heat once you start connecting a building, and then you start considering other investments related to it. Sorry, Chris, I interrupted you.
That's okay. Yeah, I think there's some folks on the line. I don't want to put anybody on the spot, but I think a couple of the larger institutional buildings downtown have probably been through a number of the retrofits and building controls. I know certainly the building we're in, which is owned by the city of Thunder Bay, has had some significant investments, and it has a lot of these sort of advanced controls that you're referencing, whether they're at the level that you're used to. But I think some of the the bigger institutions, I know definitely, the college and the university, I think, have been through a fair bit of that, and I'm sure the Government of Ontario building down here as well. I'm not going to put anybody on the spot, but so I think a lot of that's been done. I guess the sort of interest is some of these we have some older buildings here, but that's okay. Those are the real opportunity. I guess we could open up to other questions.
Yeah.
Just a quick question on the heat pumps, though, because I know this came up in the SEEP plan, a lot of our community energy and emissions reduction plan around heat pumps, and some concern about their efficiency in cold climate. What's your experience in the Nordic countries, specifically the farther northern climates? You look at Thunder Bay, which it's less and less, but we do have extended periods of -20, -30. We're talking December, January, February. It is, evenings are down below -20, pushing -30 regularly. So do they work? Are they efficient? I know this came up in a lot of discussion when there was a conversation around the consultation.
The thing is, the development has been quite good when it comes to air source heat pumps as well. I would say that it is definitely not efficient enough when you go down to -30 or so, but -20 it works quite okay. However, the thing is that to look into other, let's say, heat sources, like I mentioned about the sewage water system or other sources that is not as cold as the outdoor air, is definitely something that will increase the efficiency of the heat pumps. So they have improved air source, works down to -20 with a reasonable efficiency, but there I would say it start to get the limitations. And then it maybe have to look into some kind of hybrid systems with other water sources and so on. So yeah, that's pretty much the trend, I would say. It's a lot have happened in the past 5 years, especially if Fujitsu has released some really good air source heat pumps.
What you can also
we should also consider the use of electricity. That's high grade energy. You can use electricity for lots of things. Waste heat can only be used for heating, basically. And looking forward, we need to be able to better utilize the low-grade energy sources and not waste. We're talking a lot in UK about hydrogen. It shouldn't be used for heating buildings. That's high-grade energy that could be better served to drive cars and so on. Steve Henderson,
yeah,
I see you raised your hand.
Yeah, so I've been polite. I took away one of your comments from another meeting, Peter. See, I've learned. What also you can do in terms of integrating heat pumps is you can also you can also figure out the demand curve. So you can actually, especially combined in a hybrid situation, you can actually turn the heat pumps off when they become inefficient. So there's lots of things that you can do to play around with it to maximize the efficiency.
We have another hand. Sorry, Cotter is all I can see. Andrew Cotter.
Hi there.
Hi.
Andrew Cotter from Infrastructure Ontario. First of all, I want to just thank Michael and Peter and company for providing this presentation. You guys are really coming from almost halfway around the world. So I do want to talk about some of the more granular type of questions that I think we talked about when we did the walk around, but just want to get your sense about life cycle and redundancy of the system itself, and any customer-owned equipment. Like if we're to still keep our equipment to maintain as redundancy, just some of the logistics around that. And then if you have quite a bit of experience with district energy models around the world, what do some of the ownership models look like? Like who maintains the system? How are life cycle costs recouped? What is the life cycle of the system? It's 30 years, it's 40 years, whatever it is. And then the last piece would be, how will one of the largest hurdles of the project be addressed? And I think the location of the heating plant seems to be one of those hurdles. How is that being addressed? I know it's a lot of questions, but I think you have an idea of what we're asking.
No, I understand. Should you start, Michael? And I actually.
Yeah, I will try to pick some of them anyway. I think that the lifetime of the district heating system, it depends a little bit on what part of the system that we're looking at. I think when it comes to the pipelines, we normally expect them to have a lifetime beyond 30 years and up to 50 years. That's kind of the rule of thumb. Even when we did the financial analysis in Stockholm, we increased the lifetime there at that time. So that's what, some 20 years ago, from 20 up to 30 years, and now beyond that. And there are many substations that are still operating after 50 years even. But depending on, we have a list that we can provide also with the typical main facilities and their lifetime. But let's say that it's spanning from 20 up to 50 years, depending on what kind of main facility that we're looking at in the district heating system. In the past, many of the main facilities has been extended the lifetime due to the digitalization and modernization in that aspect. So they have simply been too outdated due to that, rather than that they are not functioning very well or that they have corroded or something like that. It's more that the control systems and so on are too old.
Yeah, I can add also, as I said, I was in the pipe business before this, and customers had a life expectancy, when they installed pipes 30 years ago, of 40 to 50 years. Many energy companies in Sweden today, they have an expectancy of 100 years when they put the pipe in the ground. And so, it's very much, it's not the pipes themselves haven't changed, but it's actually the monitoring equipment that you can monitor leaks. You can find different ways of finding weaknesses in the system so that you can replace the individual pipes that might have an issue, thereby maintaining and extending the lifetime of a network. And there are also now very good ways of repairing pipes without pulling them up. You do that while they're still in the ground. So the hardware itself you write it off, I guess, mostly in 15 years or 20 years, but then you still have an asset that can operate for another 50 years. But I'll also do the other question, and that's a very good one that you mentioned on location of the boiler, the biomass boiler. And I pick up this picture from Stockholm again. So this is an enormous piece of machinery using biomass, and it's actually located in the middle of the city. It wouldn't have been located there if you built it new today, but that's where they had their basis for their activities. So, and it doesn't create any concerns. And I think you can comment on that, Michael, because you've been instrumental in developing this system.
I just wanted to pick up on another topic that when I have it on mind there, you mentioned about redundancy. I think that is a really good point that we have to think about early, to have a redundancy strategy. Also in Stockholm, there has been the case that some new consumers who had their boilers or production capacity and things like that have kept it and are getting paid by the district heating utility to keep this kind of redundancy in strategic location of the network, so that it is possible to close down the network for maintenance and things like that, and you can still then section the network into different islands and still provide the heat and so on. And this goes both in production redundancy. So often the strategy is that if you have several boilers, then the redundancy should be at the same level as the largest boiler, so that you always have the spare capacity. And then look into the distribution redundancy also when it comes to pump stations or looped networks and things like that. But it's a very, very important topic to keep in mind from the very beginning, and important for the district heating utility to have this practice, to think about redundancy. It is really, really important. We also actually utilize mobile boilers often, both in Northern Europe and also here in Asia, which is then we have prepared the network so it's possible to hook up these mobile boilers, simply just a container, to utilize that in some critical situations. Back to
Steve, I see
Sorry, before you go to the next one, just Andrew, what about ownership models? Just a quick example.
Yeah, exactly. Yeah.
I think I will try to.
When you look, I can comment on it, how it is normally done in Sweden and Denmark. Initially, most district energy companies' activities in Sweden have been owned and operated by the communities, the councils, and that's because we had a tradition here since before having a municipality owned energy company. So it became natural for the municipalities to take an ownership. In recent years, some of these municipalities have divested their assets. When they do so, I think the model is often that you like to have a shared ownership between the city and some private investors. The Stockholm network is today owned 50% by the city of Stockholm and 50% by a group of pension funds based across Europe. So we're going to see more. We see more in Sweden of hybrid models in terms of ownership. And I think most investors also see an advantage in that cities actually have a stake in these projects, that there is a public ownership because that creates a longer term stability to the project. Whereas the cities, they feel they need the funding from private investors, but they also can bring in a lot of competence and experience when they get private investors to engage. Denmark is very much different, just to compare Sweden and Denmark. Denmark has still a regulated energy market. The tariffs for district heating in Denmark are much higher than in Sweden. The focus in Denmark has been to expand and to use the funds they can generate from district heating through higher tariffs to continue to expand the heat networks. We see in the markets we work, we believe more in this hybrid model, that will be the way forward. I hand over to you, Michael.
I think you touch upon it. This provides an overview of the most common business models. So like Peter said, most often the hybrid one is applied, and there is different varieties of the hybrid model with concession agreement, or like in Denmark, often actually it is community owned or like cooperatives that are owning so it's simply the consumers themselves that goes together and own the district heating network. And then you have the wholly public, which is most common in social regulated markets. But even in many municipalities in Stockholm, the district heating company is owned by the municipality. And it's quite rare that it is a pure private, because due to the nature of the district heating system, there is a need for public facilitation, both when it comes to permits and things like that. But also it's always good to have these anchor off-takers, the consumers, in terms of the public buildings and so on, which then naturally often result in some kind of hybrid model. So we will provide this slide also. I think the idea was in the common session, but we can include it in the slides that we're sending out after this session. And the same goes with the regulatory framework, which is quite important to think about also, because like Peter said, that in Sweden, it's a market regulation, which means that the government has very limited influence on the market, and there is not much regulations in place. There is a regulation, but it's pretty much to avoid the profits that you can take out due to the natural monopoly you have of this kind of system. So the need for customer protection is really, really important. And in Sweden, it came in place as late as 2008, this regulation. Before that, there was no regulation whatsoever. And at that time in Stockholm, given that we talked about heat demand and so on, that it's obviously the best district heating market in Sweden is Stockholm. Still, among the Swedish district heating tariffs, Stockholm was one of the most expensive, which was simply because there was no regulation there. The social regulation is typically for systems based on Soviet-style systems, so like Central Asia and Eastern Europe and so on often have social regulation. Denmark has the one called economical regulation, which is very highly regulated with very sophisticated regulatory framework, but also very costly regulation. The countries we see that are transforming from social regulation, they come to something that we would say is something between market regulation and economical regulation. That's typically where it ends up. So we will include these 2 slides when we send out the presentation.
But it's definitely often not our advice to go for 100% privately owned networks, because the thing with district heating is you start with a small, as I mentioned, call them donuts, but you want them to grow year by year. You want the organic growth in a network. That's how you make it really profitable and affordable and and a high availability long term. And it's very hard to get the private investors to have that time horizon. They can have it if they do it in combination with the city. Scott Miller, I see you've raised your hand.
Yeah, do you have, so I'm supporting a number of far north in Ontario. So these are isolated communities. They're replacing diesel with bioheat. And the challenge for them is how do they it's not just say, well, whatever savings that we did from the oil, we'll just pay to operate the diesel. So we're looking for business models that are used around the world. Our Finnish colleagues have suggested that you sell heat, but that's not, something, if you've never been in the heat business, if you're someone that's only operated a diesel heater or a diesel generator. So if you guys have any type of business models that you could share on how people, do cost recovery or actually, a business like the private business model, that would be very helpful.
Absolutely, we take note on that, Scott. Steve, I saw you had your hand raised before as well.
Yeah, it was just to touch on the sort of longevity of the networks. I mean, certainly the ones that I've come across in the UK, what is paramount is leak detection and water treatment. If you get that right, the systems should last sort of, as Michael said, in excess of sort of 30 to 50 years. But get it wrong, and depending on the sort of levels of the sort of particulates in the water, I've seen pipes go after 3 years. So it really is, one of the most important things, and I couldn't really honestly stress it enough, to be honest with you.
I will add one thing in relation to this. Share my screen again. We are collaborating, as we mentioned earlier, with various councils and stakeholders who are looking at developing heat networks or have developed and are now expanding them. This is in Scotland, in the UK, and University of St Andrews, and they have actually recently commissioned a fairly large-scale biomass district heating scheme, a similar size to, at least in the terms of heat capacity, to what we are now looking at in Thunder Bay. Longer the stretch of the pipeline, but the same method of using biomass to produce the heat. And similar number of buildings and style of buildings. So we will actually involve them in one of the upcoming sessions to have them to share their experiences in starting from scratch, so to say, using gas as the main source of heat. And often this is what we try to do, to bring stakeholders together to share experiences which are quite recent experiences. So I just wanted to highlight that they will be joining us in one of the upcoming sessions. Kevin, would you have any comments to what we have been talking about?
No, I don't have any comments, other than the fact that the study in Thunder Bay, we have identified some potential buildings, and we've done some heat loading calculations on these buildings, and we feel that there is a case to proceed with the study and make sure that we can do it in a feasible way. We have a really good opportunity in Thunder Bay with this system, and that being that the city of Thunder Bay is going to be doing some road work in the downtown north core, which would allow us to if the timing is right and we can do it, would allow us to utilize that roadwork period to put the heat pipes at least in the ground. So or some of them in the ground at least, which would minimize the impact to the overall project cost. So those are details that obviously have to be worked out, but that is one of the driving factors of the whole project. And again, there's a lot of details that haven't been worked out simply because this is a pre-feasibility study, and it is at this time just going to be a yes, let's proceed with a further study of this or further design, or know that there is no economic payback or it doesn't make financial sense to proceed with it. So it's a very high level study at this point right now, but it's we have some really good opportunities to ensure that, for cost savings on the project.
Yeah, and one topic we've discussed quite a lot so far in the project team, Kevin, is the location. As Scott mentioned, where do we locate the biomass boiler? It will be relatively close to the center, and that is obviously also an issue, not necessarily a technical issue, but more of a perception issue, and to be able to communicate to stakeholders that this does, it is not dangerous to have it there. It's not increasing pollution levels and so on. So a lot of heat networks development is about the social and communication aspects rather, and not only the technical. Chris, I think you. Or somebody tried to say something. Was it you, Kevin?
No, that was me, Peter. Sorry, it's Kevin
sorry.
again. And just, I think Andrew Cotter asked the question about the location of the boiler. I think at this time the location of the boiler is sort of up in the air. For those that are familiar with Thunder Bay and the downtown North Core area, we're looking at a study area of from the Wayland building up to Waverly Library down to Andrew's building at the Ontario Government building, maybe including the casino. So that downtown real North Core area. And those of you that are familiar with that area know that there isn't a lot of real estate available to put a boiler plant there. Plus we'll be, bringing in biomass from the bush and stuff like that. So we don't necessarily want those big trucks there. We believe, and there's some logistical things that have to be worked out as well, that on the water side, the east side of the train tracks, not in the waterfront district, but further north or south by the grain elevators or by the pool. I think it's a pool 6. Is it pool 6? I can't remember what it is, but there's some opportunities, some vacant land further out, and this all has to work in with the city's master plan on what they're doing with the waterfront areas. But that is kind of where the mindset is right now to locate a boiler plant is on that side, the east side of the train tracks, north or south away from the public, so we can get haul trucks in there, and as Peter calls them, lorries, I think is what he calls them, lorries. I call them trucks, but I get confused with the Swedish terminology at times. But no, that's what we're thinking of right now.
Great, thanks, Kevin. Any other comments? We will, as Chris also said in the beginning, we will share. We have recorded a session. I'm going to share that with you, and also obviously the PowerPoints we have used to give you time. And if you have questions, do feel free to send a mail to me or to Michael, and we will try to address the questions you might have.
Thanks, Peter. And this is Chris here again. So just if folks are interested in a little bit more about what we're doing, and as well as you can get access to a lot of the information on our case studies, the regional case studies, plus a number of the other work we're doing with our industry and stakeholder collaboration network Next for. I've put a link in the chat. Feel free to click on that, take a look at some of the tools, interactive collaborative tools we're doing around the bioeconomy, as well as some of the other work we're doing across the province. And any of the anything that we produce or publish within reason, as long as there's no IP or confidentiality, is all public. We work under a model of open collaboration. So things such as presentations and reports, we make every attempt to share to the public and display for consumption. So I'm not sure, Peter, if we've got anything else, but if I think
if there is nothing else, and great that you could join and you actually stayed with us, even though it was perhaps not that. But I hope you found it fascinating. I must say, we are nerds, me and Michael, as you can hear. And really look forward to working together with all of you in developing this project. It is, as I've repeated several times, it is about bringing in all the ones who are concerned, directly concerned and indirectly concerned, into the project at an early stage. And I think it's a great initiative by Chris and the team to do this. We actually call it the Thunder Bay model because we market this approach in other places, that they should do these kind of stakeholder meetings at an early stage when they plan a project like this. So thanks to everybody for joining today, and look forward to meeting you online and potentially someday face to face as well.
Good. Thank you, everybody.
Thank you, everybody.
Thank you.
Bye.
Thank you.
Bye now.
Bye now.
Tack ska ge, hej.